Anyway, so the committee does its best, and I think on average we do well. One of my headaches is C compatibility. Singular and BCPL leads to C with classes, BCPL leads to KNR, C with classic C going to C with classes, and there's many cross borrowings both ways, and having two committees decide what what the C committee insists are different languages with different philosophies, and I happen to disagree, but it should be compatible so that you can, individuals, tours, projects can be done both ways. It's not the way to do it. Organized by two different committees, it's a nightmare. Anyway, the successes, C++ 11 was voted in. There's a picture of the committee chairing. There's JC, he's loud. Anyway, lots of people there. Okay, everybody ships. Oh, it's not science fiction anymore. Everybody ships huge chunks of C++ 11, including all of the libraries. So here's a series of pictures, just a series of pictures. I'm not going to comment very much. If you want to see who's involved, I labeled it with people. It'll give you some idea of the individuals and the organizations behind them. Again, concentration as opposed to despair. There's Herb Soder, who's the head of the ISO part of it, and Steve Clamage, that seems to be the radical head of the American version of it. Yeah, so working. There's a happy guy from France, and I hope Alistair is voting the right way. He's certainly voting. There's more voting. I don't know why. They must be voting the wrong way because yeah, that's a happy Lawrence. Clearly, we're doing something right. Planning for the next thing. Yeah, this is the meeting where we voted out the previous standard. Here is elaborate plans on the board for how to spend the next decade. Some code. I think I'm going to not speak to it, but anyway, there's a version find all, returning a vector by value. It happens to be vector pointers. So here, we're returning a large chunk of stuff by value. This is a performance bug in C++ 98. In C++ 11, we're using a move constructor. We can move things now. It's very nice. We can do what even 3-month-old babies can figure out. I want to get this one over here, so move it over, and it's no longer here, right? End of story. We can do that with large objects, provided they are resource handles, not shown on the next slide. Other things here, there's a list being initialized with a list. You just write the elements that's supposed to be in the vector. And here I'm doing a for loop over the result of a call to that one. Simplified for loop. So there's a few things here. The copy and move semantics is one of the most important things in C++ 11. By sort of computerese, we always copy things. I mean, if the computer scientist is going to get this one over on that hand, makes a copy of this one, moves the copy over here and throws the old one away. That's the way computers work. You write into memory, when you read the memory, you still got the old one. But that's not the way the world works, right? QED. So we'll do the same thing here. We'll define for a vector a move constructor, which is the constructor you use when you don't want the old one, you just want to build one over there. So we initialize with a copy of the representation, set the representation to 0. See here V starts out with a lot of elements. We make this a copy of that and leave nothing behind. So that's the loop semantics. There's an assignment, as usually assignments are a little bit more complicated than construction because there's no object to deal with. And so the vector move with a couple of operations there. Okay, so sometimes when we are dealing with language detailers and language features, and optimizers and tools, we forget what the real problem is. And the real problem is we want to help people write better programs. We want systems that actually work. We want to make it easier to write, easier to maintain, and to get acceptable resource usage. If you give me infinite time and infinite memory, I can do things fairly easily. Those of you who know the writing book knows that sometimes the writing wins. I use that mostly in connection with concurrency, and complexity is killing us. So, in my westward drift, we reached College Station. A lot of the work for the Standards Committee was done while I was based here, and like most of the color photographs are while I was based here, and the early ones was, of course, at Bell Labs. Tamil, those were some hawks that came out of a tree in my front yard near the mailbox. A pair of hawks built a nest there. They had one baby hawk 1 year and triplets 2 years later. So this is nice. There's nice people here. You know these two. That's Pete, who helped me teach undergrads. I would have made a terrible mess out of it, out of idealism and lack of experience with people who just came out of high school. It took me some time to realize that what you really have to teach people is how to work and how to take this thing serious. There was an evaluation of the course we developed, let me just get to there, that we developed, that showed that the students in that course worked 25% more hours and preferred this course to the other courses by 20%. I mean, if you get either of those, it's very easy. We've got both. Anyway, there's sort of other people here. You know some of them. Let's see. I think there was some celebration there, and the way I got into teaching freshmen was Pete was feeding me information such as to show me what they were actually teaching people, and eventually I opened my mouth too wide and found myself in charge of it. And so you're going to teach freshmen programming, and they wanted the course, this was for the electrical engineers and the computer engineers, they wanted it done at C or C++, so that was a no-brainer for me, so I go out and find a nice textbook, right? I looked at a couple of dozen, and I was fuming. I was walking around the corridors over on the Bright building with smoke coming out of my ears. If that's C++, I can't stand it either. And eventually I wrote notes, a lot of this writing the night before and handing it out to the students. And eventually that became a book that is turning out somewhat popular too, despite the fact that people seem to read books as much as they used to. I just got the Japanese and the Portuguese versions when I came back before last year. And basically, in my opinion, programming language is just to help people express ideas. And you have to have the sort of programming techniques. It's just not a set of random facilities. And the purpose of the exercise really is to get good systems built, to make good applications. I have little patience with the sort of purely academic view that see the output of work being papers in conferences. It seems to be, it's a necessary evil, but it's still an evil. What you really should measure quality in is delivered useful things to real people. And we are nowhere near the end of this. If anybody comes and tells you that they've got a perfect programming language, that's the best programming language for everybody and everything, you know you're talking to either a fool or a salesman. We have a long way to go. Here's my summary. There's a series of languages focused on abstraction, lifting the level of what you're saying from the hardware to something suitable for people. There's first domain-specific abstraction, general abstraction, and then there's a line of development that goes, use the hardware well. Hardware is expensive, hardware is limited, you must squeeze the last cycle and bite out of it. People always say this is irrelevant. Machines have become faster and been fast enough to be wasting them for at least the last 20 years. Tell that to people running server farms, and tell that to people whose cell phone battery has just run out. My idea is to take these two things and feed them into something where you can get both. It's a little bit harder to use sometimes, and all of the languages can only do one of these things, but it's well worth doing. So we have C++, in my opinion. The key strength is software infrastructure and resource-constrained applications, and I'm still trying to find a good buzzword. I mean, the beauty of object-oriented programming is that everybody thinks they know what it means. And you can invent your own meaning for it, you can infuse your own meaning in the word. So you need a buzzword, preferably that doesn't mean anything and everybody thinks they understand, and then you define what it means. I haven't figured it out yet. Lightweight abstraction programming language, could do better. So there's some applications there, CERN, Internet, some popular C++ applications, an engine. Notice the engine there by cylinder head 5. Yes, I should mention all the high-speed trading is here. Various things, windmill programming, blood analysis, the Human Genome Project, a few browsers, hardware. There's a lot of work going on, simulating, testing, quality control, design. Things that fly. I mean, it's always fun to see things you can see. The problem with software is you can't see it, you can't feel it, but these things you can see. That's good. I'm not too keen on games, but I did some just for the sake of doing so, because there's so much of it. Thanks to Vincent for keeping this list, and basically thanks to everybody. Semi-technical talk. Yeah.
So you mentioned Bob Barton early on in the slide set here. Is that one of the fellows who was involved with CRTP?
No. Bob Barton is one of the most famous machine architects from the 60s. He built Burroughs machines, including the famous
Sorry, Burroughs?
Burroughs. Yeah. You need to go back into history and see that. But
I know Burroughs.
There's a lot of good stuff in that his design. Yeah.
So having walked through all this wonderful history, was there a single aha moment where you knew you'd done something that was going to change the world, or was it all looking back and go, oh, what you see where it all has led?
Roughly, I was so busy in the 80s that I didn't get to look in the rearview mirror. And I think the wake-up call was when I was asked to write the history paper for the Hubble 2 conference, History of Programming Languages. I think that was in '91, and I was asked organization started, suddenly I realized that maybe I should be a little bit more conscious of what I'm doing and document what is being done and why. I think I have fairly consistently in the 80s and early 90s not spent enough time saying why things are the way they are, and left other people to explain for me what C++ really is. And so they come up with things like C++ is a hybrid language that is the first early attempt on doing object-oriented programming, but my language is much better. And a lot of people explain this. And I never managed to really get over that because people still think, well, look, I don't like object-oriented programming, so I shouldn't use C++. You see that every day on the bulletin boards as an argument for, say, writing C. Because obviously, if you don't need class hierarchies, why would you deal with C++? I read a star review of my C++ programming language on Google today, on Amazon today, that had just been posted a couple of days ago. I sometimes look to see, and it praises C++ to the skies, except that it's a bit old-fashioned. It's not using enough dynamic lookup, and the standard library is sort of old-fashioned. What you should do is C#. This comes from the fact that somebody has misunderstood what he was supposed to do and evaluated relative to it. So when I realized I'd done something, and I actually was fairly conscious about why I was doing it, but I wasn't communicating it, about 90, I sort of woke up now. But it was a busy decade. Yeah?
Sorry. One would say Java, there's this cup of, see, whatever it is called, cup of the interpreter of these algorithms inside. But C++, we still bring pictures, but there is no thing to amplify you have it.
I'm not quite sure I understand the question.
What's a logo?
Yeah, oh, we want a logo. Yeah, one thing I realized, if I had thought of I mean, yeah, we don't have a C++ inside sticker that everybody who has an application should put on. It's really annoying. I'll get to this. It's really annoying to start up your browser and get the little coffee cup when they know it's a C++ program with a smaller Java facade. The same with cell phones. Yeah, I'm not good at marketing. I don't have a penguin, it would be nice. We just have that C++ in various versions.
So one of the reasons that there's no C++ logo is something you've often pointed out, that there's no C++ marketing and development organization with the budget. The committee is not such an organization. Do you ever wish you had one?
Sorry?
Do you ever wish there was such
Yes,
an organization?
yes, I have dreamed about having a C++ sort of center, C++ organization, C++ design team, and I've often thought that a small organization, maybe 5 people with people with sort of 5-year tenure mostly, who can do experimentation, who can do thought about the future, who can search out ideas, get information. People ask me how many C++ programmers are. Nobody counts them. And just being the center of the community with a budget to do unglamorous work and to be constant, not jerked around by individual organizations. I mean, the core people were brilliant. They created this organization out of nothing and wrote papers, and the main people in it were traveling the world first class, being experts in something they were creating out of nothing, and having people pay them for doing it. I thought about a C++ foundation several times, but I'll never figure out how to do it. I think it's a different set of skills from what I got. It has to be somebody with business sense and organizational skills Bjarne on the Blarney. We don't have that now. Haven't met the guy that can do it. I know Herb is trying in the library area, and if that takes off, the support site for the libraries could become a center for distribution and collection of information, but still not a cycle, a study group of things. Like we've been doing some experiments here with using pattern matching for C++ to simplify traversals. And that's the kind of proposal that's really hard to get the committee to take serious because it's outside the C mentality. Things like this. I've dreamt about it many times, a couple of times I've looked into it fairly seriously, including one in the sort of late 80s. Sorry.
Yeah, I know besides computer science you have other interests like music, history, and all of that. That's your, like, the other side of your life, kind of. So, so my question is how, there are people who believe we should not democratize computer science in the sense that it's for geeks. You have to be very good at math, which I think is good. But I also think that there are people who are good in music, that if you can make computer science of interest to them, they can develop. I personally don't see computer science like science. I see it like a tool by which you solve problems. It's not, I don't see it in the same class as biology or chemistry and all of that. So my question is, what is your view about computer science education? How do you actually get people interested so that we could probably have more people who have other interests but still need to be part of the community?
That's a hard question. We've talked about it several times in this meeting. I distinguish rather sharply with what my ideals are and what I think I can get. So let me talk a little bit about ideals in this area. I would like to see computer science to be a more rigorous, more skilled field. The idea of programmers as somebody that you can train faster than you can train a good plumber is disgusting. So I would like computer science to be something that, well, not everybody could do. It should not be a soft option. The alternative should be things like physics or linguistics, not plumbing, and that you should work for several years for it with a hard curriculum. I would probably like to see a master's degree as a minimal level for actually practicing computer science, practicing development of software. You could have a different level of developer, but they shouldn't be allowed to be lead developers. There should be a qualification. This would necessarily limit the number of people involved. The problem would not be to try and maximize the number of undergraduates in the field of computer science. The ideal would be to try and maximize the effectiveness of the people who actually did educate. We're not trying to get the maximum number of doctors or the maximum number of physicists. We're trying to get the maximum number of really effective individuals. We don't have that in computer science. And I don't see any way of getting there. I distinguish rather sharply, as I said, between ideals and what I think we can get. On the other question about what it takes to be an educated person, as opposed to just being a technical expert, I do believe strongly that you should have a life and interest outside the technical education. A friend of mine says, let us quote him, that's too arrogant, but you should have something else. I mean, I like music, I like history, I read a bit of literature, I sort of like traveling, took most of the photographs you saw there. So there should be a full life, or that's separate. I think, yeah, that's a different problem. People have to find time for that in their lives. Okay, thank you.